everyone. I'm Jonathan Brendefur, and if you've been watching the last few videos, we've been talking about strategies for multiplication to build fluency and flexibility. So making the argument that flexible, 4 different strategies for becoming more flexible helps us become more fluent and actually leads us into being more prepared for algebra. So the last strategy we talked about was compensation, and I had made the point that you can use it for multiplication to figure out different multiplication facts or problems, and you can also connect it to algebra. So I'm going to show you how that works. So in this case, we're going to actually compensate both numbers to 20 times 20. So what that looks like with the area model is we're going to compensate the 18 all the way to 20, and we're going to compensate the 19 all the way to the 20. That gives us a nice area of 20 times 20, which is equal to 400. So I'm going to do that with the equations. 20 times 20 is equal to 400. But with the compensation, we didn't actually have 20, we only had 18. So here, this was too much. So that was too many, 220. So I'm going to actually subtract off 2 20s. So I'm going to subtract 2 20s, which is subtract 40. So that is subtract 2 times 20, which is equal to 40, or take away 40. I also compensate the 19. So I'm going to take away here that entire amount here, and I'll explain why I'm doing that. And we'll use a different color here. So here with the 19, I'm going to take away I'm going to take away 120. So I'm taking away 20. Now at this point, I could look at how much I have here. I had the 400, take away 60. That would leave me with 340. But something happened here and I'm not quite done. If you notice, like if this was a strip of paper and I compensated it out to 20, I have these 2 20s, I actually remove this entire amount. That leaves me with only an 18 amount, but it was easier for me to subtract the entire 20. That means I subtracted this little amount right here twice, which means I got to add one of them back. That little amount is a 2 by 1, so I'm going to add back a 2 by 1, which is 2. If I have that sum, that is that 340 plus the 2, which is 342. So I know then that 18 times 19 equals 342. So the area model helps us get a sense of what's happening with the compensation process and then the notation to go along with it. So there's something about visually having that in our head to really understand the process. Okay, now I'm going to look at that algebraically. Let's say x is equal to 10. X could be anything, but in this case, we're going to say x equals 10 just to make this example. So in this case, we're going to say 18. We would represent that as 2x, 2 times 10 is 20, subtract 2. So we have that expression here, 2x minus 2. 19, if we look at the same way, then we're going to multiply that by 20, which is 2x. But to get to 19, I have to subtract 1. Okay, now we're going to do this distributive property that you learned in algebra. I'm going to do it in a slightly different way to kind of make the point here. So in this case too, we said 2x times 2x. I'm going to distribute that amount. So I have 2x times 2x, which is 4x squared. In this case, I'm also going to take this one and go -2, distribute that to 2x, so that is minus 4x. Then I'm going to distribute the 2x to the -1, so that's minus 2x. You might have learned it in a slightly different way, but it's still fine, still works out. And then I have to distribute the 2 to the -1, so -2 times -1, which is plus 2. So the goal is that the 2x has been distributed times each of the amounts in the expression, the -2 to both expressions, which is labeled there. It matches this, is why I was doing that. So if I substitute the 10 in for the x, that gives me 10, so that's 4 times 10 squared minus 4 times 10 minus 2 times 10 plus 2. So then we can actually see this relationship of 4 times 10 squared, which these are actually the 10 by 10, which is 100, 100, 100, and 100, which gives us that 400. So you still see that in that same relationship if you were to graph it on an XY coordinate system. Then we're taking the 4 tens, which is really 10, 10, 10, and 10. So that's where we get the 40, subtract the 40. And then here, I have a 10 here and another 10 here. So it's breaking everything back down to that x value of 10, which is minus 20. And then, same type of thing, we're going to add the 2 back. So now we have the 400 minus the 60 plus the 2, which gives us 362. So a lot of times in algebra, we're asking, why are we always at the very end when we have a negative times a negative here, we're adding 2 back? How does that even make sense? This gives you a sense of when you have a rectangular figure and you're using algebra to erase out 2 different amounts, but you're taking it away at twice where you have to add it back. So that's a nice connection for why compensation works well for strategies with multiplication, especially larger numbers times larger numbers, and then that connection to algebra. So hopefully that was helpful in conceptually understanding multiplication, how it leads into algebra and why it's so important. Thank you.